Okay, what we did was we changed out this pulley. So we went from a 12-tooth pulley to a 20-tooth pulley, trying to increase the speed on this. So I had to get this pulley, had to broach it out for the keyway, same as I did with the original one. So we fit it to the shaft. Oh, there goes the keyway. That's one thing we did, and we'll check that in a minute. And another thing we did was when this motor was installed, it goes through this plate like so. And I had this open here, and if you notice in the other videos, I put a piece of tape on here to keep the dirt from getting inside that bearing. So what I did was I drilled and tapped 2 832 holes so I could make a cover for this. Keep the dirt out of there. That's one thing I did. And another thing I did was that when I'm using this unit, I have it on the bottom shelf of the bench, and I have to lift it up and put it on the machine. And the only place I could grab it was on the motor and the indexer, and it was really kind of hard to handle, difficult. So I had these bars made. One of the guys was using the bending machine, so I had him bent me up a set of these handles. Now this is 1/8 tubing, 1/2 inch OD, 3/8 ID. I have one for the back and I have one for the front. So what I did was I made up these, since this was 3/8 ID, I couldn't thread into it, so I made up these, I guess you call them standoffs. It's just a piece of 1/2 inch OD, and I drilled and tapped 390 diameter to about where this cutout is. I think this was 1/2 inch from here to here. Then I made this 3/8 plus. So I didn't want to have to drill and tap the whole thing, so I used a 1/4 20 bolt, and I drilled a 265 1/2 inch deep for clearance for the bolt. And then I drilled and tapped the rest of it. Now the end of it is just basically a saw cut, because this flathead bolt is going to come in from the bottom of the plate and attach these onto the plate. And what I'm going to do is I'm going to weld these onto here. Probably put some tack welds, just maybe 4, maybe 5, 6, I don't know. I'm not good enough to weld it all the way around and make it look nice, so I'll probably just tack weld it in different spots. But anyway, after these are tack welded on here, I'm going to set them up in the machine. So this is down in parallel, and put a couple of 5/8 pins in the ways of the machine, and then take an end mill and just face these so that they'll be true with each other and parallel to this piece. So when I bolt it down, it'll be flat. It won't rock. I can always put some, I thought about making this out of thicker material and putting a counter bore in there and stabilize it a little bit. But I think what I end up doing is just bolting this down and putting some washers, 1/4-inch washers on here. And that'll act like give it a bit of bigger surface to stabilize it. So I think that'll work just fine. But I made 4 of these. 2 for this one, which is going to be the back. And then 2 for this one, which is going to be the front. Now the front had to be smaller because I got less room to work with in the front because of the unit. I need clearance on the unit. I don't want to crowd the unit so that I don't have clearance when I'm going to make a cut. That's a pretty good fit. It didn't have to be that tight, but so anyway, that's the plan with that. And I'm going to, like I said, put a cover over this thing, keep the dirt out. Now, the more I think about it, the more I'd like to get a encoder put on here. See, when this goes through here, I got a little shaft sticking up. And I can make this piece longer. But I'd like to put an encoder on here because when you set your degrees, the unit goes to those degrees, but you're not actually sure that that's where it is. Especially when you're dealing with, multiple degree modes, you want to know where it is. So I saw this thing on YouTube, Reading Absolute Encoder with Arduino, November 14th, 2016. And he shows an encoder that goes from 359, then it starts at 0 again. And that's kind of what I'm looking for. A lot of the other encoders, they just read, I don't know what they read, it's points or pulses, but I mean the numbers, they just, they go past 360 and they just keep going up 400, 500, 600, depending on, how you turn the unit. And that doesn't really help you. Then you got to sit there and convert all those units into degrees. And I'm not really sure on how to do that because I'm not kind of a, electrical person. But maybe somebody out there knows something and knows a way we can attach an encoder to either this motor or the indexer itself. But that would be a nice feature to where you have a little screen that tells you what degree you are in relationship to the part. So what I did was like I said, I changed this from a 12 to a 20. And in the last video, I changed the steps on the motor, which I don't know what it's going to do, but I guess we'll find out because I got this all hooked up and I'm going to turn it on and see what kind of rotation we got. If it's the same rotation as before, then that's fine too. I was trying to speed it up a little bit in between indexes, but being I'm going from a 5 to 1 to a 3 to 1, it'll be a little bit faster. But if I can change the steps on the motor to make it even faster, I mean, I'm not looking for grease lightning speed, but I just want to be able to index it a little bit faster. So I'm going to turn it on, and I have the unit here, and we're going to see if it increased the motor. So I'm going to turn it on. I got to turn the power unit on. So we'll go to divisions and put in 4. That looks like it's a little faster as far as the RPM on the motor is. I don't know if you can see that. We'll just put a little mark on there. I think it's a little faster. I don't know, not grease lightning, but so we're going to change it to 1. Divisions 1. So see how many times it rotates. Well, it rotates 3 times, which is right. 3-to-1 ratio. So it's going to rotate 3 times. The indexer is going to rotate 1 time. But I guess we'll put it all together and see how it works out. Now on the, you remember before I put that brake unit on there, and that's because I was having slop in this, slop in the gear, and I went back and I looked at this, and I have a little bit of slop here too. So on the original one, it's got these set screws in it. And there isn't much room for that set screw to work. It's probably 1/8 inch thick there. So on this one, what I did was I put the keyway right where the set screw was. So I could put the screw in there and clamp down on that set screw, which is going to clamp down on the keyway, which is going to clamp down on the shaft. Now, this was a big boss on here, so I turned that to a smaller diameter for about 20 thousandths. So I put a little boss on here, because when it fits on this bearing, you want it to ride against that inner race. You don't want it hitting this aluminum piece. So I turned that diameter down, so I had a little boss on there so it would ride on that bearing and not hit the aluminum piece. So I made it the same size, the same height as the other one. I clamped it on the table, a couple clamps, and I put this on the table and brought my cutter down to the top of here, made that 0, and just faced this off until I got to 0. Then I put it on the lathe and I turned that so I had room there, and there's still some threads there. See, it started getting into those threads, but I still have I mean, it maybe got into 10 or 20% of the thread when I turned it. I mean, I probably could have drilled and tapped another hole somewhere over here or wherever, you know, as long as they're 90 degrees apart, but I felt that this was good enough. So what I did on this keyway was I put a little angle on here, a little 45, so the set screw comes down and it hits that key and it wedges it. So it'll clamp down and wedge it at the same time, because the keyway wasn't long enough to hit on the surface of it. It only hit on the end of it. So I took so 90 degrees from that, I put a little flat on that shaft so that the keyway, the set screw would hit that shaft and not gouge the outside of the shaft, because that's a diameter there, and I didn't want the set screw to go in and dig in there and raise up the diameter on this, and that way, you know, if you go to pull the gear off, it would bind, because now you got an interference fit from when that set screw went in and it dug into that shaft. Now, that didn't have to be very tight, but you know, you snug it down a little bit. So just to save all that, I just went ahead and put a little flat on there, and I could have extended this keyway out, but you know, it'll work fine the way it is. So that's where I am now. I'm gonna take this back to work and put it back together, and we'll see what happens. Yeah, another, you know, when I hardwired this into here, see, the only way I could get this switch out, because the nut is on the inside of here, so I can't really take this apart. And what I should have done was, I knew that it was a mistake, but I should have left a little more length on this wire, and I could have put a little clip in there so I could disconnect it and reconnect it. And I still might do that if I have to continually take this on and off for whatever reason. But I really didn't see a reason to take it off. But you never know, you know, and so it's an afterthought. But it's something I should have realized from the very beginning. So that's you don't want to really hardwire it in like I did. You want to be able to put a connector in there somewhere. All right, well, that's where I am now. I'm gonna go out and tack weld these things on there and face them off and get this thing installed so I can get this thing back going. Yeah, we had a little interesting job come through. and it's this is part of the job, and that was one of the reasons why I wanted the encoder. This is a little drive dog. This part here, there's a bushing that goes in here, and there's 3 splines on here, and we have a little 3-axis Analam, which I could go in there and I could do all this, rotate it, do all that. The same thing with the spline area, you know, throw it off center, do one side of the spline, throw it off center, do the other side of the spline. I mean, it's a lot of work, and that's one of the reasons why I wanted the encoder. But then, you know, I was thinking that, you know, there's also the encoders that will actually move the motor to a position. Instead of reading the position, it'll actually move it to a position. So that's something I'm thinking about too, is I could add another motor or modify this motor to where I could set it to a position, but I wanted to keep it simple at first. You know, I just wanted to make sure the thing worked. So now that it works, we're trying to expand its capabilities a little bit so it can do a little more, I won't say difficult work, but a little more intriguing work. Instead of just drilling holes and indexing, we can make it do other things too. So that's something I'm thinking about looking into, and we'll kind of go from there with that. All right, see what happens.